When we graph polynomials, I'm going to give you a polynomial just like I did right here, this cubic polynomial. And then I'm asking you to sketch the graph of this, but then I gave you the fact that x minus 1 is a factor. So when I give you that second part like that, you know now that you can do division to break down this cubic into a quadratic that hopefully we can continue to factor, and then we can find all three of our zeros. We know that we're going to have three zeros because the power, the highest degree of this polynomial is 3, which tells us there's going to be 3 zeros. Now, we might not be able to solve for all three, and if that were the case, then they would be non-real. Okay, so I'm going to do synthetic division since I can based off of my divisor here. I'm going to do 1, 5, 2, and -8. I don't need any placeholders. And then I know that I'm going to do the opposite, and I'm going to use 1 using synthetic division. I'm going to drop down the 1. 1 times 1 is 1. I add the 5, I get 6. 1 times 6 is 6. I add that down. 2 plus 6 is 8. And then 1 times 8 is 8. And my remainder is 0. Now it's really important, since I told you that x minus 1 is a factor, you know that your remainder has to be 0. It has to be. If you don't get that, you did not use the synthetic division or any division correctly. Alright, so now we have a quadratic x squared plus 6x plus 8. Alright, so can this be factored? Yes, it can. What multiplies to give you 8 that adds to give you 6? 2 and 4. So I'm going to have x plus 2 and x plus 4. So my degree told me that I was going to have 3 factors, and I do. I have 1 from the beginning, and then I just solve for 2. So let's graph these. So since these are my 3 zeros, before I graph, I have to solve each of them. So technically what I'm going to do is I can set it equal to 0 and figure out which problem. So this is going to be a little mini problem. This, set it equal to 0, that's going to be a little mini problem, and so is this. So the 3 solutions that you're going to get, x is going to equal 1, -4, and -2. And these values, these solutions, represent our zeros, where the polynomial is going to cross the x-axis. Okay, so now we're going to sketch. I know that I have a 0 at 1, at -2, and at -4. Alright, now, our original function was a cubic. It was x to the third. And our leading coefficient was positive. It was just x to the third. So since our leading coefficient is positive, for our end behavior, we know that since it's positive, it's going to end up. Now, since it was cubic, that tells you that the end behavior is going to be opposite because it's odd, opposite. So that means we start down. So now I'm going to draw in my end behavior. I always do that first. I check to make sure there's no multiplicity, and then I can connect the dots, and that's my function. When you do sketches like these, your end behavior and the values of your zeros, those are the only 2 exact things you know. The fact that this graph, goes so high and goes so low, it's not exact. We don't know. So that's why it's just a sketch, because I could also make it look like this and go bigger with my turns, and that's still correct. Alright, we're going to sketch another cubic function, except this time I gave you a factor that has a coefficient in front of our linear term, the 2x plus 5. So this means we're going to do long division. So let's jog our memories and review how to do long division. Alright, so I don't need a placeholder, so this is going to be my dividend, my original function. And then 2x plus 5 is going to be my divisor. Okay, so we're going to do the first term of the dividend divided by the first term in the divisor, and we're going to get x squared. And I'm going to put that over top of the squared term, or the quadratic term, in my dividend. Alright, now what I'm going to do is I'm going to take that x squared and I'm going to multiply it through my divisor. And then I'm going to get 2x to the third plus 5x squared. And with long division, we're going to subtract. Alright, so my first terms cancel out, and then 11x squared minus 5x squared is going to be 6x squared. And then we bring down this minus 21x. Again, first term in my dividend, or my new dividend, and my divisor, and I'm going to get 3x. And then I'm going to take 3x, I'm going to multiply it by my divisor, 2x plus 5, and get 6x squared plus 15x. Alright, now I'm going to do the subtraction problem, which is going to be negative 21x minus 15x, and I'm going to get negative 36x. Let me try to change my colors. And then I bring down this minus 90 and we do it all over again. 36x divided by 2x is going to give me minus 18. And then when I multiply it through, I should get a remainder of 0, which I do. And that's because we know that I told you this was a factor. So you should get a remainder of 0. If you don't, your division is incorrect. Alright, now we're going to take that quadratic function and then we're going to factor it. Alright, so we have x squared plus 3x minus 18. So what multiplies to give you negative 18? That adds to give you positive 3. You're going to have x plus 6 and x minus 3. Alright, so when you solve these two, you're going to get x equal to negative 6 and 3. And then don't forget that in our original problem, we had 2x plus 5. So if you set that equal to 0 and solved, x would be negative 5/2. So these are the three zeros that we're going to graph. Alright, so my first step is to graph these zeros. Negative 5/2 is negative 2.5. Alright, so we had a cubic function and we have three zeros. That totally applies. The next thing we need is our end behavior. We had a positive coefficient to start, which was 2x to the third, so that means it's going to end up. This one is also cubic, so it's going to have opposite end behavior, which means it's going to start down. So just like the last one, it's going to start down, it's going to end up. There's no multiplicity, so we're going straight through.